Hi guys, how are you doing? So I hope that the pseudocode was clear to you, and there was one test case which I felt that it need to be discussed, is that what if the element being searched is not there in the array. For example, let's say this is our array 10, 20, 30, and what if we want to search 15, for example. What happens if we search 15? So we definitely know that 15 is not in the array, so let's see what happens. So this is L, this is R, and this is M. So the algorithm will first check if a of M is equal to 15 or not, and we get to know that is no. Then it will see if a of M is greater than 15. It's yes. So it will make r equal to m minus 1, so it will become 0. So now r is r is pointing over here. So now m is 1, m is 0. So it will check if a of m is equal to 15. Is no. So it will check if a of m is greater than 15. It's no. So it will make L equal to m plus 1. So it will become 1. So it will become 1. So now what happens is that L is 1 and R is 0, and there is a condition for the while loop that L should be less than or equal to R, which definitely is violated over here. So it won't enter into loop, So where will it go? It will go to this command. So it will return -1, which means that the element which was being searched in the array is not found. So yeah, I hope that the example on the element being searched is not there in the array is clear to you. Now the next thing that we need to see is that what is the time complexity of the code. So what's the time complexity? So if we try to develop a recurrence relation for this function, then it will become if we try to develop a recurrence relation for this function, then it shall become t of n is equal to t of n by 2 plus 1, because in each iteration we are calling a function which would be dealing with half the elements of the array. So that's why it's tn by 2. Now if we try to use substitution method, then it shall become t of n by 4 plus 1 plus 1, which is equal to t of n by 4 plus 2. So after k such steps, it will become t of n by 2. It will become t of n by 2k plus k. And there is one thing that we know is that t of 1 is 1. So what we want to do is that we somehow want to make this thing equal to 1. So for doing that, n by 2 raised to power k equal to 1, so which means that 2 raised to power k should be equal to n, which means that k is equal to log of n. So yes, so now we would be putting the value of k into this expression. So we'll get t of n equal to t of 1 plus log of n, which is equal to 1 plus log of n. So from here we get to know that t of n is equal to O of log n, and this is far better than O of n, which was the time complexity of linear search. So now we know that why binary search is better than linear search, because it's having lesser time complexity than linear search. And yes, and if we talk about space complexity, then the space complexity would be O of 1, because there is no additional memory that's required for the algorithm to work. So yes, so the time complexity of algorithm is O of log n, and the space complexity of the algorithm is O of 1. I hope that the time complexity and space complexity was clear to you about the binary search algorithm, and stay tuned for further videos on algorithm, and thank you so much.